Stay safe, happy learning, say no to theft of electricity for the first time every time. India is one nation, one grid, and one frequency, with its power transmission system supplying peak demand of approximately 2,50,000 megawatt, and maintaining stability of the system is of paramount importance. In this video, let us discuss the stability of power system. Let us consider a synchronous motor connected through a transformer to a large power source. The power delivered to the motor depends upon the voltage of the source, internal voltage of the motor, and phase angle between these two voltages. The phase angle depends upon the position of the rotor of the motor. The power delivered to the motor when it is running at constant speed is of course equal to the power output of the motor plus running losses of the motor. If the mechanical load on the motor is increased, the motor cannot supply the entire load until its power input increases. Therefore, the motor slows down. The phase angle between the internal voltage of the motor and the voltage of the system increases until the electric power input to the motor is equal to the power output plus losses. While the angle is increasing, the excess of the power required by the motor over the electric power input is supplied by the stored energy, oftenly in the form of flywheel connected to the system in the rotating system. As the motor speed decreases, the stored energy supplies part of the load. If the motor oscillates around the new point of equilibrium and eventually comes to rest, the application of load has not caused the motor to lose stability. If the increase in load is too large or is applied too suddenly, if the increase in load is too large or applied too suddenly or removed too suddenly, the motor may lose synchronism, in which case the stability limit is said to have been exceeded. If the reactance of the transformer or the transmission line between the motor and power source is increased, the likelihood of maintaining stability is decreased, as well as we will see later in this video. Lines having increased impedance and lower cost become practicable with the advent of voltage regulators. But the increased reactance presented power system engineers with a more acute problem of stability. The rapid development of power system in recent years was interrupted only temporarily by the depression of early 30s, and as the individual power system grew, so did interconnections between them. The interchange of power between different power companies in India and the long distance transmission of power now possible are a tribute to the ability of transmission engineers in India and other countries to solve the stability problem in spite of the high reactance that is inherent in long lines between sources of power and the load. The stability may be defined as a further the stability may be defined as a condition among synchronous machines in which the angular positions of rotor of the machines relative to each other remains constant when no disturbance is present, or become relative to each other remain constant when no disturbance is present to become constant following an aperiodic disturbance. I repeat, a further definition of stability is to describe it as the condition among a number of synchronous machines in which the angular position of the rotors of the machines relative to each other remains constant when no disturbance is present, or becomes constant following an aperiodic disturbance. I repeat, aperiodic disturbance. The stability limit is defined as the maximum power which can flow past a point in the system without causing loss of stability. The term stability and stability limits are applied to both steady state and transient conditions. Steady state stability limits refers to the maximum flow of power possible through a particular point without loss of stability when the power is increased very gradually. Suppose the generator is generating 200 megawatt and load is suddenly increased from 30 megawatt to 130 megawatt, there may be loss of stability. Or load is 180 megawatt load is drawn, suddenly 150 megawatt is withdrawn, that then again it may be there may be a loss of stability. So flow of power possible through a particular point when the loss of stability, without the loss of stability, when the power is increased very gradually or decreased very gradually, is steady state stability. The transient stability limit refers to the maximum flow of power possible through a point without the loss of stability when a sudden disturbance occurs. The transient disturbance may be a sudden increment of load which could be carried without stability, carried with stability if it were applied gradually, but which causes the loss of stability because of rapidity of application of the load. More often, the disturbance for which we want to know the transient stability limit is caused by a fault by switching one of several parallel lines out of the circuit, or by a combination of fault and its subsequent isolation by disconnecting part of the system. Because every system is subject to transient disturbances, and because the transient stability limit is almost always lower than steady state stability limit, transient stability will be given should be given most of attention in transmission line. In some cases, steady state rather than transient stability may be the limiting factor in systems overloaded after the decay of the transient. A very simple power system consists of a generator or motor connected to an infinite bus. Infinite bus is nothing but a source of constant voltage and frequency. Almost as simple is a system containing only two synchronous machines. Since the machines located at any one point in a power system usually act together, it is customary in stability studies to consider all the machines at one point as one large machines. So 510 megawatt machines should be considered as one 550 megawatt machine. When studying the performance of one machine connected to a large system, the system may be considered to have constant voltage and constant frequency. That is, the system is assumed to be an infinite bus at the point of connection of the machine. Thus, a multi-machine system sometimes can be reduced to an equivalent of two machine systems. The factors affecting the stability of two machine system or stability of one machine connected to an infinite bus are the same as those which influence a multi-machine system. That's all in this video. Thank you. Stay safe. Happy learning. Please check your subscription so that you don't miss next video from this channel.